Welcome to the Explainer. You know that humming, clicking box sitting right there on your desk? Well, today we are taking a journey deep inside of it. We're going to bridge the gap between abstract microscopic science and real practical shopping advice to finally demystify how these everyday machines actually work.
It's so easy to take for granted, right? You hit print and just walk away. But the science happening behind the scenes of a simple printout is absolutely incredible. And honestly, once you understand these hidden microscopic mechanics, choosing the exact right machine for your home or office becomes incredibly clear. So here's our roadmap for today. We're covering 1. The great printer dilemma. 2. The magic of xerography. 3. 6 steps to a page. 4. Laser versus inkjet. 5. Ink, toner, and costs. And finally, 6. Choosing your perfect printer. All right, let's jump right into part 1, the great printer dilemma, and that overwhelming choice in the printer aisle. To solve this buying dilemma, we first have to look at something called xerography. Now, what is that? Basically, it's a dry copying process based on electrophotography that creates an invisible electrical blueprint to guide toner. Sounds like sci-fi, right? It literally turns an everyday, boring office task into a highly complex, almost magical scientific process. Which brings us to part 2, the magic of xerography and creating that invisible blueprint. When you peel back the plastic shell of a laser printer, its macroscopic anatomy actually resembles a complex miniature factory floor. The heart of the entire operation is this central cylinder, known as the photoconductor drum. But before a single piece of paper even gets involved in the process, an invisible blueprint actually has to be drawn right onto that drum. And that brings us to the laser unit. Think of this as the printer's master map maker. It uses a tiny laser diode and these incredibly fast rotating polygon mirrors to translate your digital data. I mean, every single word, every line, every image from your computer is translated into physical, precise electrical instructions. It literally takes your digital bits and bytes and turns them into a physical map made entirely out of static electricity. How wild is that? Moving on to part 3, 6 steps to a page and the journey from digital to physical. You know that incredibly fast action you hear when you hit print? It happens so fast it feels completely instantaneous, but it actually builds through 6 very precise stages. First, we start with charging the photoconductor drum, then exposing the image with a laser, developing it with toner, transferring it to your paper, fusing it permanently with heat, and finally, cleaning the drum so it's perfectly ready for the exact next page. Let's break those down. Step 1 relies on something called the Corona device. This thing uses microscopic tungsten wires pumped with a massive 6,000 volts. That intense electrical field ionizes the air and drives a strong static charge directly onto the drum. You are essentially harnessing controlled mini lightning right inside a desktop box. Then, in step 2, we expose the drum. The photoconductor is fascinating because it holds on to its electrical charge in the dark, but it immediately conducts electricity the second it's hit by the laser's light. As the decay time chart shows, by draining the charge only where the light hits, the blank spaces on your document remain highly charged, while the text areas are totally neutralized. Okay, step 3 is a mouthful. Triboelectrification. Here, microscopic toner particles are given a static charge, so they literally jump off magnetic carrier beads. They fly through the air and stick only to that laser-drawn map on the drum. It's basically static cling, but engineered to absolute microscopic perfection. After step 4 transfers that static powder from the drum onto your paper, step 5 kicks in. This uses hot roll pressure fusers, heating up to a staggering 130 degrees Celsius to melt the thermoplastic toner directly into the paper fibers. Seriously, 130 degrees. This is exactly why your paper feels so nice and warm when it comes out of the printer. Finally, step 6 simply cleans away any leftover microscopic dust. Now for part 4, laser versus inkjet, the ultimate printing face-off. So now that we know exactly how laser printing works, let's compare it directly to the inkjet. The starkest contrast here is the base technology itself. As we just learned, lasers use dry, statically charged powder fused with high heat. Inkjets, on the other hand, literally propel tiny, wet droplets of liquid ink through microscopic nozzles directly onto the page. So at the end of the day, you were choosing between melting plastic powder or spraying liquid dye. Because of that fast-rolling magnetic brush technology in the laser printer, they can just blast out 20 to 40 crisp text pages a minute. Inkjets, they average about 5 to 15 pages. But where inkjets completely dominate is in vibrant, complex photo quality. They can smoothly blend those tiny wet droplets of color in ways dry powder simply can't.
Which leads us to part 5, ink, toner, and costs, and looking beyond the sticker price.
These two totally different mechanical approaches create entirely different cost structures over the lifespan of the machine. The price you see on the box at the store is really only half the story. Inkjets are cheaper up front, but they're expensive to feed. Plus, liquid ink can dry up and clog the nozzles if you don't use it regularly. Lasers, while they require a higher initial investment, but they offer a much lower long-term cost per page. Why? Because that plastic toner powder never dries out. And finally, part 6, choosing your perfect printer, the final buyer's guide. Armed with this new knowledge of static electricity and microscopic nozzles, your buying decision should now be logically obvious. You should absolutely grab an inkjet if your priority is creating beautiful, vibrant photos on glossy paper or printing really complex color graphics. For visual artistry, it's hands down the ideal machine. On the flip side, you definitely want to invest in a laser printer if you are churning out massive, text-heavy documents and want a fast, highly efficient machine. If you're looking for lower long-term costs and the absolute peace of mind knowing your powdered toner will sit patiently without drying up between print jobs, a laser printer is the clear winner for sure. So, after learning about the invisible electrical maps, the 6,000-volt corona wires, and that 130-degree melting process, will you ever look at a freshly printed piece of paper the same way again? Next time you grab a warm page right off the output tray, you'll know the incredible microscopic magic that put it there. Thanks so much for joining me for this explainer, and stay curious.